Maths and Science series welcomes you guys. This is Elton. Before we continue with the lesson, I would actually like to thank those who subscribe to the channel. If you haven't subscribed yet, please make sure that you do the right thing. And guys, let me just brief you about our services. During the week, we are having contact classes from the early hours of the day with those that are upgrading their physical sciences and mathematics results during the week in Phosphorus. Then on weekends or during weekends, we are with those that are still in high school, from grade 10 to grade 12, doing physical sciences, mathematics, and life sciences. So for more information, we will actually leave our posters at the end of the video. So please make sure that you WhatsApp those numbers that you will see there. So today we'll do organic molecules, which are it is the study of mainly carbon, or the molecules containing carbon atoms. So it's very important for us to know the properties of carbon. So carbon atom, it is found in group 4 on the periodic table, meaning that it has 4 valence electrons, remember, and it is surrounded by 4 bonds. So that's very, very important. Look at these two, look on these two carbon atoms. So these two carbon atoms, they share the middle bond, or they share the middle single bond. Then each one of these two, they have, or they are surrounded by 4 bonds. That's very important, guys, for you to know that in organic chemistry, you must know that each and every carbon atom, it is surrounded, or it is to be surrounded by 4 bonds, exactly 4 bonds. If you don't actually have the structure that has the carbon atom surrounded by 4 bonds, that structure is incorrect. I hope you guys understand this. So that's very, very important in this concept. So we have 2 terms: homologous series, which is a series of organic compounds that can be described by the same general formula, and the functional group, which is a group of atoms that determines the physical and chemical properties of a group of organic compounds. So make sure that you know how to define these 2 terms. So if we talk about homologous series, for us to understand what a homologous series is, since they're saying that a homologous series is a group of organic compounds, we are talking about different compounds. Then a functional group, we are talking about the symbol or the sign that will actually make us to conclude that this is this type of homologous series, or is that type of a homologous series. I don't know if you understand that, guys. For an example, in our community or in our province, we have different types of schools, right? We are all called schools, but with different names. The name school is the homologous series, but the different types or the different names of the homologous series is the school: Boxbeck High, Phineas High, Letulwazi, Afrikaanse Work School, and all of these schools that we know, they are all known as the homologous series, or we can just say all the different types of schools, they are what? They are homologous series. But the functional group is the badge of the jersey of the learner, that when we see this brown jersey, we can see that no, this learner is a learner from Falcon Secondary School or Falcon High. Why? Because we saw the color of the jersey or the badge of the jersey. So homologous series are different types of the schools with different names. So what is it that is going to make me to say that this is Phineas High School? It's because of the badge of the jersey, meaning that the badge of the jersey becomes what? The functional group. I don't know if you guys understand that. So that's how you actually differentiate between the two. Homologous series, different types of the schools, and the functional group is that exactly thing or sign or symbol that makes you to conclude that this learner is from Tuto Lesedi. Why? Because you can see the badge of the jersey. I don't know if you guys understand that. I hope that I tried explaining homologous series and the same functional group. So that's very, very important. That's important. So it's very important for you to write down these 2 definitions and to know how to differentiate them and to know how to actually define them, because it's very, very important for you to know them. Each of them contains 2 marks. So these are homologous series. Remember, you now know what is a homologous series. We have alkanes, alkenes. As I said, that we have different types of homologous series. All of them, they are homologous series, but under homologous series we have different types of the series. I don't know if you guys understand this. So these are the homologous series that we're going to talk about. Okay, so make sure that you know them. You know how to say that since this is an alkane, what is it that makes me to say that this is an alkane? That's very, very important. So we have this table, the number of carbon atoms as well as their prefix. So if we have 1 carbon atom, the prefix will be meth. If we have 2 carbon atoms, it will be eth. If we have 3 carbon atoms, it will be prop. 4 buts, 5 pens, 6 hex, 7 hepts, 8 octs. These are prefixes. Okay, let's talk about alkanes, alkenes, and alkynes. These are known as hydrocarbon atoms. Write that down. And we have saturated. We're saying that alkanes are saturated and alkenes are unsaturated, and the alkynes are also unsaturated, but they are more unsaturated than alkanes. Why? Because they have a triple bond, and the alkenes, they are less unsaturated than the alkynes. Why? Because they have a double bond. Then alkanes, they are saturated, meaning that they contain single bond between the carbon atoms. Alkenes are unsaturated. Why? Because they have double bond between the carbon atoms, or between the C atoms. Then alkynes, they are more unsaturated. Why? Because they contain a triple bond. So it's very, very important. Let's check or look on the structures of the alkanes and alkynes as well as alkenes. So as you can see, the structure of an alkane or alkanes, they are separated by the middle single bond, meaning that what makes me to say that this is an alkane is the functional group, which is a single bond. What will make me to say that that structure is a structure of an alkene is because of what? The double bond separating the 2 carbon atoms. What makes me to say that the structure of the alkynes is an alkyne structure is the triple bond. So it's very, very important. Alkanes, alkenes, and alkynes, they are known as hydrocarbon atoms. So it's very, very important, guys. All of them, they are homologous series, but what can make us, or what is it that we can use in order for us to differentiate them? The functional group. So how can we differentiate between these? A single bond, those are alkanes, double bond, alkenes, triple bond, alkynes. So that's very, very important, guys. Make sure that you actually write this down as you are watching that. So important. You must know how to define saturated compounds, unsaturated compounds using the exam guideline. That's very, very important. So I think we can actually move forward. We have hydrocarbons, organic compounds that consist of hydrogen and carbon atoms only. We have 3 of them. They are known, or they are regarded as hydrocarbons. Why? Because they are, or they consist of hydrogen and carbon atoms only. So those are the general formulas of these 3 different homologous series. Alkanes is CnH2n plus 2, alkenes CnH2n, alkyne CnH2n minus 2. So these are actually the general formulas. Remember, alkenes, alkanes, and alkynes are known as hydrocarbon atoms. Why? Because they consist of hydrogen and carbon atoms only. So we have something known as IUPAC naming, and we have rules to follow for us to name all our compounds. You consider the longest chain, you consider the functional group, the thing that will actually make you to conclude saying that this is an alkane, right? Then you consider the branch. We have two types of branches, which is a methyl branch. Write it down: methyl branch and ethyl branch. So these are the three rules for you to follow in order for you to give the IUPAC name of any structure or any compound. Consider the longest chain. Then you consider the functional group and the branch. Suppose we are given this structure. It has 4 carbon atoms, and you can see that the longest chain is 4 because we don't have branches here, right? And what functional group do you see here? We only see single bonds between carbon atoms, meaning that this is what is an alkane. Its name is butane. Why? Because it has 4 carbon atoms. Now here we see 3 carbon atoms, meaning that the prefix must be prop. And what functional group do you see? It's a single bond between carbon atoms, meaning that we will not actually consider the functional group. Why? Because it is all over the structure, unlike with alkynes and alkenes. So this, since it has 3, it will be propane. Why? Because it is what is an alkane. Now look at this. We have a branch in carbon number 2, so that's a branch. So if we can count from the left to the right, actually the longest chain is a straight chain, meaning that we must consider what the functional group, single bond, meaning that this is an alkane structure. Then consider the branch. We start on the side that it is easier for us to find what the branch, and the branch, when you start either from the left or the right, it's in carbon number 2. So it's so important that whenever you start calling or you start naming the structure, you start by the branch. It is like the branch becomes now a prefix before the prefix of the number of carbon atoms. I don't know if you understand that. I'm saying that the branch name becomes the prefix of the carbon, or of the number of carbon atoms. I don't know if you understood that. So we have a methyl branch. So this is a methyl branch. If it was actually we're having 2 attached carbon atoms, it will be an ethyl branch. I hope you understand that. So since we are having 3 carbon atoms as the longest chain, meaning that the prefix of this structure, it will be prop, right? That will be the prefix. And we considered the functional group. We saw that the single bond is all over the structure, making this structure to be an alkane structure. I don't know if you understand that. And as you can see that each and every carbon atom, it has 4, or it is surrounded by 4 bonds. That's the most important thing. So let's try to name it. Since carbon atom, or since the branch is in carbon number 2, it is known as 2-methyl propane. After methyl, do not put the hyphen or the dash. So you actually combine the branch name as well as the IUPAC name of the structure. So it is 2-methyl propane. Why? Because the branch, or the methyl branch, it's in carbon number 2. I hope you understood that. Here's another structure. As you can see, we have carbon number 1 up to carbon number 6, meaning that the straight chain is the longest chain. And in carbon number 5, we have branches, and also in carbon number 3, we do have a branch. Remember, we said that we consider the longest chain, so we see that we are having 6 carbon atoms, meaning that the prefix, it will be hex in a structure of an alkane. Then we consider the branch. We have 3 types of the same branches, methyl branches. But remember, I said that when you name the IUPAC of this structure, you do what? You start by mentioning the branches. It's like they are becoming the prefix of the carbon, or of the number of carbon atoms. I hope you heard that, or you understood that. So this is a what? It's an alkane. Why? Because I see single bonds all over the structure. I hope you guys are understanding this. So just give it a try and pause the video and try to write the name of this structure. I'm waiting for you to write it, then I will write it for you. Then you can actually mark yourself if you got it correct. But I trust you that you are getting this. So remember the 3 rules. You consider the longest chain, you consider the functional group, you consider the branch, and you start on the side that it is easier for you to get what? The functional group. But here we are having the single bond all over the structure. We can start anywhere. So we have 2.2.4 hyphen trimethyl hexane, meaning that we have a carbon, we have the branch in carbon number 2. We have 2 branches, right? Then also in carbon number 4, since we have the same branches, or the same methyl branches, since there are 3, we're saying it's trimethyl. But if it was 2, we're going to say dimethyl. I don't know if you understand that. So here's another structure. From left to right, let's consider the functional group 1, 2, 3. Let's consider the longest chain from left to right. 1, 2, 3, 4, 5, 6, 7. We have 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We can say that the longest chain is the straight chain is the longest chain. Then we have branches from left to right. We have a branch in carbon number 2, which is the methyl branch. Carbon number 3 is the methyl branch, and also in carbon number 4, from left to right, we're having a methyl branch. So that's how a methyl branch is shown or drawn. From left to right, if you can count the carbon atoms from your left to your right. In carbon number 4, we have how many? We have an ethyl branch. Then in carbon number 3, we are having a methyl branch. Then also in carbon number 1, 2, 3, 4, 5, 6. From your left to right, we have a carbon atom that has a branch attached to it. I don't know if you understand that. So we know that between methyl and ethyl, if you can actually write them down, ethyl and methyl, which alphabet from these 2 branches comes first whenever you are actually telling us about the alphabets A, B, C, D, E, F, G. Remember, ethyl and methyl. Ethyl, E comes first before, or E comes before M, meaning that all our structures, if we have 2 different types of branches on the carbon chains of each and every structure, we are going to start by actually making the ethyl branch to be the first branch to name. Why? Because it comes first. Even when you do what, you actually call out the alphabets, or naming the alphabets. So that's very, very important. If you have 2 different types of branches, make sure that you do not start with a methyl, start with an ethyl. Why? Because it comes first. So since the ethyl branch is in carbon number 4, we're going to say 4-ethyl hyphen. Then in carbon number 2, we have a methyl branch, and also in carbon number 5, we do have a carbon, we do have a methyl branch. So it is going to be 4-ethyl hyphen 2.5, meaning that in carbon number 2 and in carbon number 5, we have what? A methyl branch. So it is going to be 4-ethyl hyphen 2.5 dimethyl heptane. So that's very, very important, guys, for you to actually know. This is actually organic chemistry or IUPAC naming. It has a lot of marks if you're going to know those 3 rules and follow all of them. It's very, very important. I hope we are understanding each other so far. Yeah, so I think we'll move forward, guys, because we're done actually giving the IUPAC name of these alkanes structure, or this structural formula of this compound. Okay, how many carbon atoms do we have? A straight chain, we have 4 carbon atoms. And in which carbon atom does the double bond lies on? In carbon number 2, meaning that this is an alkene. We have a methyl branch, so it is 2-methyl butane. Why? Because the branch is in carbon number 2, so it's 2-methyl but 2 in. That 2, it means that the last 2 before in, it shows that the double bond is on the second carbon. Then this one is a straight chain, therefore the branch, not the branch, but the functional group, which is the double bond, is in carbon number 2, meaning that the prefix is going to be but. Why? Because we have 4 carbon atoms. So this one, I think it's straightforward. This one is straightforward. So let's try to actually give the IUPAC name. Remember, you consider the longest chain. It's a straight chain. Functional group, it is what? The double bond, meaning that this this structure is an alkene. Therefore, there's no branch. I think we can give the IUPAC name, it's but 2 in, meaning that the double bond lies on the second carbon between carbon atoms. So it's but because we have 4 carbon atoms, so the prefix is going to be but, then but 2 in, the IUPAC name. And this is a straight chain, then the double bond is on the first carbon. Then there's no branch here. How many carbon atoms do we have? We have 1, 2, 3, 4, 5. Therefore, the prefix is going to be pent. It's going to be pent, so there's no branch. All of the 3 rules are actually followed. So you cannot actually know how to name these compounds or structures without following those 3 lines, those 3 rules. So make sure that all the time you start on the side that is easier for you to find the functional group. So it's going to be pent 1 in. Why? Because the double bond is in carbon number 1. Do not write pentan 1 in. No, it's pent 1 in. If it was a but, is not butan 1 in, it will be but 1 in, but this one it's pent 1 in, not pentan. Okay, as I promised, guys, so these are our services. This is a poster for those that are upgrading their physical sciences and mathematics results during the week, every day from 8 o'clock in the morning. And we are located in Vosloorus. For more information, please do WhatsApp that number you see on your screen. Then the following poster is for high school students from grade 10 to grade 11, whereby we are offering mathematics, life sciences, and physical sciences. So for more information, please make sure that you do not forget to actually take our WhatsApp number and inquire for information. Yes, so we are not online, but we are doing contact classes in Vosloorus. So for more information, do not forget to actually WhatsApp us, or even call us, or email us. So we'll do the second part of organic chemistry, whereby we're going to talk about the other homologous series and finish all of them. All right, thank you guys. Please do not forget to subscribe to the channel, like, share, and comment. Thank you guys.